Hello and thanks for watching Gary Teaches Maths. I'm going to continue going through the Edexcel higher tier paper from 2018. So we're up to question 7. This question is about transformations. So there's several types of transformation. There are enlargements, there's rotations, reflections, and translations. So this one actually is starting off talking about reflecting a shape T, the one drawn, in a line. So we're reflecting shape T in a line x equals -1, and we've got to then draw shape R, which is the reflected version of shape T. So the first thing to do would be actually to draw this line x equals -1. So I'm just going to do that. So a line x equals -1 is actually a line which goes through the point x equals -1 and is a vertical line, so it would look like this. Okay, and if I reflect this shape in that line, what it means is that every point on this shape is then placed exactly the same distance but on the other side of the line. In fact, we could even draw a dotted line to the line of reflection from our shape, because we've crossed over 3 squares there, and we'd end up then the reflected point of this would be the same distance but on the other side. So we go 1, 2, 3, and it's placed there. 3 squares on the other side of the line. We're then going to do the same with all the other corners. So if we take this corner here, then that's going to be 2 squares to the line. So we go the same distance on the opposite side and we end up there. And then we're also going to take this point here, and that's going to go, that's 4 squares to the line. So we've got to go 4 squares on the other side. So that means we're going to end up there. And if we join them up, what we end up with is our reflected shape. There we go. So this is our shape R. The next thing that we need to do is we need to reflect shape R in the line y equals -2. So the line y equals -2 is there, and we've got to reflect this shape R in it. Now, line y equals -2 is a horizontal line, so just draw that in. Like that. Oops. And we can see that the reason why that line is the line y equals -2 is because every point on this line has a y coordinate of -2. So if we reflect R in this line, we again do the same process, taking one of the points here. We can see that we've actually crossed 3 squares to get to the line, and it's got to be right angles that we're crossing this line, and we'll go the same distance exactly on the other side of it. So that would mean that our new shape would have a corner there. We'll do the same with this point. So it's 1, 2, 3 squares to the line, and then 3 squares on the opposite side. So that's going to take us to there. Finally, this point is 5 squares to the line, and we're going to go 5 squares on the other side, which is going to take us there. So you can see 1, 2, 3, 4, 5. And again, we join them up. So there we go. 1, 2, 3. And this is shape S. Okay, so the final point of the question is we're being asked to describe the single transformation that will map shape T, our original shape, onto shape S. So let's have a look at that with regard to the available transformations. So we can ask ourselves, is it an enlargement? Well, it's the same size actually, and so I think we can discount that one. It's neither enlarged or reduced in size. We've been doing reflections, and we can see that there's no real line we could draw, not even a diagonal line, which we could do a reflection in that would give us shape S. So we can discount that. A translation, if you do a translation, the shape that you translate always ends up with in the same orientation, i.e. this shape here, which is T. If I was to translate it, it could potentially look something like that, i.e. it would be exactly the same way up. Now we can see that shape S isn't the same way up as shape T, so therefore it can't be a translation. So in order to describe our single transformation, first thing we can say is it is a rotation. So it's a rotation. Okay, rotation. And a rotation, the way we look at a rotation is, you could imagine placing a piece of tracing paper. So I'll try and pick a fairly light colour. Imagine this was a piece of tracing paper over our shape there, T, that we wanted to rotate. We could put our pen in that tracing paper at some point. So, and in this case here, and we could spin the shape round, and if we've done it in the right place, it would then, once it's been rotated into this quadrant, it would exactly cover the new shape. So we can see if we rotated this piece of tracing paper, moved it around into this quadrant, then it would indeed cover shape S. So it is a rotation. Now to describe this fully, there's a couple of things we've got to describe. We need to know the angle of rotation, and we need to know the center of rotation. So that means the coordinates of the point that we've rotated it about. Okay, so first of all, let's list the center of rotation, the coordinates here. So we can see that that is just -1, -2. So that's the coordinates of the center of rotation, -2. And the angle of rotation, if we were to draw a line from the center of rotation to one of the points there, then we'd have to say, right, let's also draw to the reflected version of that point, like there. And we can see what angle is that rotated through. So there we go, this is the angle it's rotated through, and we can see it's rotated by 180 degrees. So the angle of rotation is 180 degrees. Now, usually we'd be asked to find the direction of rotation, and that is either anti-clockwise or clockwise. Now in this special case, because it's 180 degrees, it doesn't matter whether we went anti-clockwise or clockwise. So we could go in that direction, or in fact we could go in that direction. So we don't need to put the direction of rotation in this case, because it's a special case of it being 180 degrees. If it had been 90 degrees, then it would matter which way we'd gone, whether we'd gone clockwise or anti-clockwise. Okay, so this is our final answer. We've actually said that it's a rotation. The angle of rotation is 180 degrees, and the center of rotation, the coordinates of the center of rotation, are -1, -2. And we've done it. So thank you for watching Gary Teaches Maths. If you've liked this, if this has been of help to you, there are more videos available. You can see them either on my video channel on YouTube, or by looking at our website, which is bestmathstutors.co.uk. And if you like the video, please subscribe and like our video. Thanks very much for watching.